Hi, everyone. Thanks for joining today's SAM System Advisor Model webinar. I have just about 1 o'clock on my end here in Colorado, so we will go ahead and get started. Today's webinar will be discussing modeling the hybrid power systems in SAM. It's going to be a bit of a brief overview of a new capability that we have, followed by a live demo of that capability in SAM and plenty of time for questions and answers afterwards. My name is Janine Keith. I'm a senior engineer at the National Renewable Energy Laboratory and excited to be walking through this with everyone today. This is the third webinar in our 2024 webinar series. For those of you that are here, you've probably already found the registration link, but you can also find the webinar recordings of the previous webinars on our website, sam.nrel.gov, and we will be posting a recording of this webinar as well. A little bit of housekeeping. In the GoToWebinar interface, we're showing 2 screenshots of ways that you can ask questions during the webinar, depending on if you're using the desktop application on the left or the instant join viewer on the right. I have several of my colleagues online as well that will be helping with questions, and either one of them will type an answer to your question during the presentation, or we will be saving it to answer during the Q&A session at the end of the presentation. To get right into it, today we're talking about the System Advisor model, which also houses the PV Watts model. SAM and PV Watts are free software that enable the detailed performance and financial analysis for a variety of different kinds of renewable energy systems. These models are available as a desktop application, which is what we're going to be covering today. PV Watts is available as a web tool and API, and both SAM and the PV Watts model are available as a software development kit, including the popular Python package called PySAM. The code is open source. We have extensive documentation and user support, and so lots of ways to interact with the tool and get help with it should you need it. We like to give people a flavor of the usage of SAM to help put things in context. The desktop tool is started once every 1.4 minutes around the world, and the PV Watts web API receives over 17.5 million hits per month. So we do believe that these models are helping a lot of analysis, which really motivates us to add useful features. I also have on the bottom left a graph of Google Scholar citations, so papers that have been published using SAM, and a quick capture on the right of the mix of geographic locations of some of our users. So about half US usage and half international when we took this snapshot. So with that framing, I'd like to jump right into hybrids in SAM. And I wanted to start with the definition because there are lots of different definitions of hybrids out there in the industry. When we say hybrids in SAM, we mean more than one type of power generating technology in a single grid connected plant that is optionally coupled with storage. And we decided that we wanted to add this type of hybrid to SAM in a streamlined user interface form. For a couple of reasons. It had previously been possible in the SAM desktop tool to add cases together, or if you were accessing SAM via scripting or PySAM, you could add different technologies in your own script. But that technique had some disadvantages. It was pretty clunky to use, definitely not obvious, and it was not easy to use parametrics. So if you wanted to look at a couple different iterations of a hybrid plant, that was pretty labor intensive in the user interface especially. And as hybrids become more common, we thought that there would be several advantages to a more streamlined user interface in SAM. It allows people to easily analyze the financials of the hybrid system as a whole, to vary the subsystem sizes or technologies, and to seamlessly use our built-in parametrics tool, which I will demo a little bit when we get to the live demo. I'll note that we have a couple different technology combinations, and I know this is a busy slide, so I'll spend a little bit of time going through it. The first 4 bullets here show the different kinds of new hybrid power combinations that we have. So we have the option, that's top one is the simplest. It's a combination of PV watts, which is our simple photovoltaic model, the wind power model, and battery storage. The second one is the same combination, but you could add fuel cells. The third one lets you swap in our detailed photovoltaic model, which has more control over the exact components that you're using in the PV system, with the wind power and battery storage model. And then the last one is quite a combination that combines PV watts, wind power, the battery storage, but also adds a fuel cell and our generic system model, which can be used to model any other type of generating system that might be coupled in a hybrid way with some of these other technologies. But I want to mention specifically, because we do get questions when we talk about hybrids, a lot of people use the word hybrid to refer to just a PV battery system or a wind plus battery system. And so we get the question, well, is PV battery, can I model that in SAM? The answer is yes. We have had PV coupled battery for many years in SAM. I have a screenshot here of the technology selection pane, which I will show in my demo also, but I've circled some of the different storage coupled options that are relevant here. For most of the combinations where it is just a single electricity generating plant coupled with storage, those are housed under that green energy storage category that I've circled in the screenshot here. So different iterations of PV plus battery or the generic system plus battery, which can be used to model batteries in conjunction with any technology that isn't explicitly coupled. So the example of maybe wind plus battery, you can run a wind model in SAM and export the generation profile from that into our generic system model, which just takes some type of generation profile, and then model that coupled with battery. And I'll mention that we are hoping to add more technology combinations, add storage to more things. A lot of the availability of our models is dependent on funding availability. And I also want to mention that apart from the battery storage that I'm mostly focusing on today, we do have thermal storage that is largely located with our concentrating solar power models and industrial process heat models that are circled in yellow on this slide, as well as standalone thermal storage under our energy storage category. So a lot of different kinds of storage available in SAM. And we do apologize for the confusion in this technology tree. We had some underlying architectural constraints that, for example, have us with the fuel cell plus PV plus battery option outside of the hybrid configuration category for now. But we are hoping to address that in a future release and make it a little bit less confusing. I also want to note on this slide that when we're talking about a hybrid system in SAM and throughout this presentation, I will be referring to a specific component of the system as a subsystem. So in the PV plus wind plus battery example, the PV plus wind plus battery would be the hybrid system, and just the PV part would be a subsystem, or just the wind part would be a subsystem. So I think it's helpful to frame what kinds of questions we're envisioning people might answer with these hybrid models. Of course, we always love to hear from people about the types of questions you're interested in. So some of the things that we've thought of or talked with folks about so far are looking at what kind of hybrid system can I design for 24/7 carbon-free energy for an industrial electricity client. An alternative one would be, how could I add PV to my existing wind plant to maximize my interconnection agreement? Or how could I take advantage of complementary wind and solar resource profiles at my location? And I'll also mention using that configuration that has generic system in it, you could also analyze, how could I use wind and solar to complement my fill in the blank generation? It could be some type of existing fossil generation or another plant that you're looking to model adding wind and solar to using that generic system model that I mentioned. And of course, this isn't an exhaustive list of the different types of analysis questions you can answer, but a few ideas of what we had been envisioning when we were implementing this feature. So the hybrid models are available as of SAM version 2023.12.17, which is our release last fall, and they will continue to be available in future releases. The addition of the hybrid capability was jointly funded by Southern Company and the DOE Solar Energy Technologies Office, CETO. And it's currently available with a subset of our financial models. So either the single owner model, which is the most common front of the meter financial model, or the third party host/developer model, which is a behind the meter model. It has a bit of a confusing name, but it really allows you to analyze the perspective of both the person owning the system, so the developer, and the person who is using the electricity, so the third-party host or that large industrial client, if you think about the analysis questions that I posed in a previous slide. I'll mention that these hybrid capabilities are also available in our PySAM Python package, and I have a link here. We will be posting the slides afterwards as well to some more information about that Python package. Throughout this presentation, I'll be mentioning other things that I'm not going to cover in great detail because I am focusing on hybrids, but I will try to provide resources for getting more information about those parts of SAM, and you can always check out our website for more information on any part of SAM. I wanted to dig in a little bit to the assumptions of our hybrid system models. I have on the left here things that are differentiated per subsystem and things on the right that are applied to the entire system. So to start with things that can be differentiated per subsystem, you can specify a different resource location for the energy generation technologies, although I will get to the asterisk at the end of this list. You can specify, obviously, the subsystem specifications, different by subsystem, so the PV specs different from the wind specs. And you can specify installation and operations and maintenance costs by subsystem as well. Then on the right, things that are applied to the entire system is what we're calling hybrid system installation and O&M costs. And I will get more into the difference between those on the next slide. The interconnection limit and curtailment, financial parameters, revenue, incentives and depreciation, and any applicable electricity rates or electric load for behind the meter systems. I wanted to outline these explicitly because it currently is the case that these assumptions do best represent a physically co-located system if you set the resource location to be the same for each of the energy generating technologies. Now, you could use the model to represent systems that are not physically co-located, but we don't have a great way to deal with different financial parameters or revenue or incentives or transmission losses that you might have to take into account if you are modeling physically separate systems at the moment. To go into a little bit more detail on the installation and O&M costs, I will also show this in my demo coming up just next. But we've added a new user interface page to represent installation or O&M costs that are shared by the entire hybrid system. And I have a screenshot of that page here. It's worth noting that because there are two different ways to input your installation and O&M costs, users need to evaluate which costs are applicable to the entire hybrid system and which ones are subsystem specific, and adjust all of the cost inputs accordingly. So as you'll see when I get into the demo, there's a little bit more back and forth in the hybrid system models between input pages than we have typically found with some of our other single technology models. So without further ado, I will jump right into a live demo. And I have here SAM open on the screen, our 2023.12.17 version. And I will go ahead and click the Start a New Project. And this is the screen that I had that screenshot of in my slides. I'll quickly show that this is where the other energy storage options are. The fuel cell PV battery option is down here. Some of our thermal storage options are standalone in the energy storage categories or coupled with our concentrating solar power or industrial process heat models. But we're going to be focusing on this hybrid category today. And I am going to, for the purposes of this demonstration, use this simplest model. It has many similarities with the other models, so it's useful for demonstrating sort of the workflow. And for my first system, I'm going to use the single owner model, which again is that front of the meter option that we have for hybrids currently. If I click OK, you'll see that it pops up, as SAM users will be used to, the list of different input pages on the left here. If you're not familiar with the overall layout of SAM, I will again point out our SAM website, which I will link towards the end of the presentation, sam.nrel.gov. We have lots of introductory videos to different kinds of technologies and sort of the overall user interface. So you can get more information there if you're new to SAM completely. But for now, I'm going to assume that most people are a little bit familiar with SAM and point out the new features specific to the hybrid models. So at the top, we have a new category here for hybrids specifically. The first page is a summary of the hybrid system. So this is where in one place for this configuration, you can look at how much PV and wind capacity I have, what my battery size is, and what that total generation capacity, so the sum of the PV and wind, is, to help you make sure that you're sizing things together the way that you're hoping that they will be. And I will also point out, as I always do, our help button in the upper right corner that does have context-sensitive help. So this will bring you to a page explaining what each of these calculated values is representing. Or on other pages, it will talk about the inputs on that page. So that can be a helpful resource if you're getting a little confused about what something means. I'll also point out the new hybrid systems cost page. This is where you can input costs that apply to the entire hybrid system. So both the installation costs and the O&M costs. And as I will show, you would also need to modify the costs of the individual subsystems if they are replaced, if the hybrid system costs are replacing anything that would normally apply to just a subsystem. So I'm going to go ahead and set up sort of a simple system. I am going to use a lot of the defaults in SAM, but I'm going to set up a system in Pueblo, Colorado, which is not too far from where NREL is located here. On my PV Watts location and resource page, I have already downloaded the Pueblo weather file for the sake of speed of this demo. Again, we have other videos showing more about downloading and using solar resource in SAM, so I would encourage you to check that out if you have questions. But I've selected the Pueblo weather file here. And then I'm going to skip over to my wind subsystem. And on the wind resource page, because I want to model a physically co-located system, I'm going to pick the Southeastern Colorado wind resource file that ships with SAM at the moment. So now I have my resource files in roughly the same location. From there, I'm going to think about my system sizes that I want for each of my 3 subsystems here. So on the PV system design page, I want to model something a little bit smaller than the default system. So I'm going to go ahead with a 50 megawatt DC PV system, which gives me roughly 40 megawatts on the AC side using this PV Watts model. And on the wind side, I'm going to skip over to my wind farm page. I have an option that lets me specify the number of turbines to define the size of my farm. I'm using the default turbine, which is a GE 2.5 megawatt turbine. So on the wind farm page, I'm going to go ahead and say that I want 5 turbines in a row, and I'm going to start with actually just 1 row of turbines, which will give me a 12.5 megawatt wind system. Now, remember, if I want to take a look at how those 2 generator system sizes are interacting, I can click back up on the hybrid system page and see, okay, I have about a 51 megawatt plant of generation capacity. So then I'm going to go down to the battery page, and I'm going to go ahead and specify my system size here. I want a smaller battery to go with my 51 megawatt system here. So I'm going to go with a 10 megawatt battery that has 4 hours of storage. And again, for a lot of the other specifications for all of my subsystems, I am using a lot of the defaults. I'm trying to show the most relevant inputs for the hybrid system, just to do a quick demo and overview of how you might use this model. So now that I've set all of my sizes together, I want to take a look at my costs. For the sake of time, I'm going to imagine that I am just getting hybrid cost savings on O&M with this plant. So I'm going to go ahead to my PV operating costs here and set this default O&M cost to 0. I'm going to do the same thing for my wind operating costs down here, which are a default of 40. I'll set that to 0. And the same thing for my battery. Just assuming that I'm, making up a fictitious savings in O&M costs by having a hybrid system. So on my hybrid system costs page, I'm going to assume that instead of the roughly $60 per kilowatt AC per year that would have been the total of those 3 subsystems, I'm going to get a savings so that it's only a total of $45 per kilowatt per year. So this is what I mean when I say that you need to make sure you're modifying the subsystem costs for anything that is accounted for in your hybrid system costs. So this can be a little bit of an accounting thing, but that's one of the considerations that you need to make when you are trying to model a hybrid system in SAM. Now, the last set of tabs here are our usual financial model pages, which again, we have a recent webinar going through the front of meter financial models, and we have webinars on behind the meter that I would encourage you to check out if you want to learn more about the financial models themselves. But for the sake of this demo, I am just going to go ahead and change the assumed revenue. I'm going to say that in Pueblo, I've been able to get a PPA agreement for 7 cents a kilowatt hour that has a time of delivery factor from 4 to 9 p.m. of 1.5 times my normal price. So a fairly simple structure. Again, I've completely made it up. I don't know that that's actually a PPA I could get in Pueblo, but for the sake of this demonstration, that's what we're going to go with. Now I'll go ahead down towards the simulate button. For those who are familiar with SAM, you'll notice that there are fewer options here for now. That was one of the things we needed to do in order to get this hybrid modeling capability integrated, was to actually nix some of our other modeling options that are usually available and are still available if you're looking at single technologies. So our options right now are just simulate, parametrics, and macros. I'll go ahead and simulate my system here and show what kinds of results we get for the hybrid system. So for anyone familiar with SAM, you'll notice that this looks quite a bit like some of our other results summary pages. We have our usual metrics table that gives the total generation for the entire hybrid system, and it talks about the usual financial things. So levelized cost of energy, PPA prices, the net present value, etc. That again, there's other information on the SAM website if you're wanting to dig more into what these metrics mean. But for the hybrid systems, there's also a table that gives you generation by subsystem. So I can take a look and sort of spot check. For example, my DC capacity factor for the PV system is 22.5%, and my capacity factor for the wind system in an AC basis is 37%. So each of those systems are performing okay from a resource perspective. I can also take a look at my battery round trip efficiency. And I can see here the contribution to my energy generation from PV in blue and wind in gray. I can take a look at heat maps of the annual energy generation of PV and wind, which you can see are sort of complementary in this location. And then some graphs of the cash flow for the lifetime of the system and the annual generation for the lifetime of the system, which is subject to degradation. I'll also note that our usual results tabs, there are several of them available at the top here, so you can look into a lot more detail at different outputs on our data tables page. You can look at the cash flow for the system, which is now broken out by subsystems, so you can see the O&M that applies just to PV, just to wind, just to battery, etc., as well as the sum for the system. And then you can do a similar kind of thing with our time series graph. So this is what my generation looks like for the first year. I can zoom in on a couple days and see my overall generation is not totally following a solar production profile, although because the PV system that I set up is larger than the wind system, it is a little bit closer to a PV profile of production. But what I do quickly want to show is how I might then use parametrics to take a look at this system. If you'll recall, the net present value that I got for this system was negative, and that might not be what I'm going for. So let me go over to parametrics here. And we do have a video showing how to use the parametrics, so I'm not going to go into it in too much detail, but I'm going to do a quick analysis on the system, the relative PV and wind system sizes, to see if I can change that net present value. So I'm going to take a look at the system nameplate capacity for PV watts and the number of rows in my wind farm, which will change the number of turbines, changing the wind farm capacity there. And for an output, I'm going to take a look at my net present value because that was the one that I was hoping to try to change by modifying these system sizes here. And I'm just going to quickly manually change my relative system sizes. I'm going to slowly increase my PV, or I guess start at 60 megawatts and go up to 100 megawatts for 5 different iterations on my PV size. And then my wind size, I'm going to go ahead and do the opposite. So I'm going to go from 5 rows down to 1 row. And if I go ahead and run these simulations, you'll see I get my little race of which one's going to finish faster on my machine here. And then we can take a look and see if I can get that net present value to move in the direction that I'm hoping it will. And so here I have just a quick graph of the net present value for each of those runs that I set up. And you'll see that I am actually able to identify a crossover point here where my net present value is more positive with a smaller PV system and a larger wind system in this particular location, which in Pueblo, that maybe makes sense. And the trend is possibly reversed in other locations of the country. But this is a way that you could use the parametrics to take a look at sort of the relative size of different kinds of the subsystem, or if you were trying to make different design decisions, do I want the PV system to be tracking or not, that kind of thing. And this was one of the reasons that we did want hybrids integrated into the user interface, was so that it would be easier to use this existing parametrics functionality to do some of those analysis decisions. I will note that SAM is not a sizing optimization tool. There are other sizing optimization tools, but we do think people tend to look at the relative sizes of systems in the parametrics tool, as well as other design decisions that you can make. And to finish out my demo, I'm going to quickly show the behind the meter hybrid option, again with the simplest PV watts, wind, and battery hybrid. I'll go ahead and look at that distributed host developer model, which again is behind the meter. You'll notice that the input pages for the technologies and even the financial parameters are a little bit similar. We have the addition of electricity rates and electric load, and the financial parameters look a little bit different for this host developer system. But the technology pages are the same for the hybrid system as the ones that I just demoed. The defaults are just slightly smaller systems. And for this quick demo, I'm actually not going to change any of the default batteries, but I wanted to quickly show how you could take a look for that 24/7 carbon-free energy system analysis that I mentioned in my slides. So I'm going to go to the battery page, and the only thing I'm going to change is I'm going to look at the battery dispatch. And I'm going to choose this new self-consumption option. So this can be used for behind the meter systems to maximize the amount of power that is consumed by the person hosting the system, or the person that has the electric load, being offset by the hybrid system generation. And I'll note that this dispatch option is available for non-hybrid configurations as well. We have a webinar last year going through all of our battery dispatch options in more detail that you can find on the SAM website if you're curious for more about the dispatch options. But if I go ahead and set that option here, I can click simulate. I'm going to leave all of my other defaults the same for my hybrid system, which is perhaps not a super financially feasible default system at the moment. It's not well matched to my load perhaps, but what I want to show is in this data table, if I go ahead and search for the number, type it correctly, the number of time steps that my electric load is met by the system, which is an output that shows up when you choose that self-consumption dispatch method. I'll just take a look at year one, and I'm running an hourly simulation. So there are 8760 time steps, and 8303 of them are met by my hybrid system here with the largely oversized system for my electric load. So this is what I mean by the type of workflow you might have if you're trying to look at system designs to provide 24/7 carbon-free energy for an industrial client, as one of the other ways we imagine people using this behind the meter option for hybrid systems in SAM. And with that, I'm going to go ahead and flip back over to my slides just to wrap up quickly and leave plenty of time for Q&A. I like to make sure to emphasize we love to hear from users. So this Q&A is a great place to ask questions, but I wanted to link some other resources as well. We have a YouTube channel, which is where we post all of our webinars, and we will be posting this one as well that I've linked here. You can get help, report bugs, request new features, or tell us how you're using SAM at our user support forum on our website, sam.nrel.gov/forum. I also like to note that if you're comfortable with GitHub, that is where our team tracks bugs, feature requests, and development progress on our repositories. So I've linked the wiki to our main GitHub repository that talks a little bit more about the project. We are also more than happy to transfer things from the forum to that GitHub repository. If you are not a person who's comfortable with GitHub, that's totally fine. And there is a lot more great content on our website, as I have been saying throughout this webinar. So please check out sam.nrel.gov, which is where you can download SAM and see some of the other videos that I mentioned and learn more. So with that, I will go ahead and wrap up and open it up for the Q&A.
Thanks, Janine, for that introduction to modeling hybrids in SAM. We have a few questions coming in through the questions window. If you do have a question, feel free to type it and we'll answer it. We have a couple here that we haven't answered by typing answers that are both related to wind. And the first one is, can PV plus wind without battery be analyzed here?
Yes, that is a great question. I'll bring up my SAM demo again. We don't have a specific PV plus wind only configuration, but you can use this PV wind battery configuration and set the battery size to 0 to analyze a PV and wind system without a battery. And I'm going to hope that I remember all of the appropriate inputs to set to 0 here. And we'll see what I get. If I've missed some, my team can jump in. But you can see I've got some not a number results for my battery, which I think means it disabled it the way that I was hoping to. And this allows you to take a look at relative generation and the financial parameters for just PV and wind. To be safe, you'll probably also want to zero out installation and operating costs for the battery, just to make sure that nothing in the battery is showing up in your analysis where you don't want it to. So the answer is yes. While there isn't an explicit PV plus wind only option, you can model it by zeroing out the battery inputs in the PV, wind, and battery hybrid configuration.
Thanks. And a couple of follow-up questions are coming in. Here's one that's says, just wanted to verify, but if we just wanted to model wind and storage, we would build a wind model and then use the results to build a generic storage hybrid system model?
Yeah, so there are basically two ways you could do it, I guess, if you're looking at just wind and battery. So one is what I mentioned in the slides where you would set up a wind model. You'd get the electricity generation, which I can demo quickly. So I've picked a no financial model. I'm just going to simulate it with the defaults. And you'll see my data tables here show me the system power generated. So you can copy this, which I'm going to do by clicking Control-C at the moment, and then add the generic system model with whatever financial, the energy storage generic system with battery option, with whatever financial model you're interested in. And then on the power plant page, you import a generation profile. So I can edit that, excuse me, and just paste in, which I would probably have to do by not clicking Control-C and Control-V, paste in the generation profile from that wind case. So that is one way to do it. The other way to do it is very similar to the PV plus wind only option, and I'm going to go ahead and close all my cases here and start a fresh one. You could also use the PV wind battery hybrid option and zero out the PV inputs to look at just the wind and battery. So that's an option as well. Again, you'd need to make the system capacity 0. And then you would also want to zero out, just to be safe, the costs and the O&M costs to make sure that you're not getting any PV type of generation clouding your wind plus battery analysis.
Great. Here's one. Can we load wind and solar EYA done separately from another software and load it into SAM for analysis?
If you have two different generation profiles that you've done separately, probably the best thing to do would be to use that generic system model. And so you would have your profiles that you've created for both wind and solar from another tool. You would add them together exogenously to SAM, and then you can use this generic system battery option, again, with whichever financial model you're interested in. And you can import that hourly or sub-hourly generation profile from an external tool, or you can paste it into this column here to basically have SAM model the battery and the financials interacting with the generation profiles that you've created in a separate tool. So this is the most common way that we use other tools, generation profiles interacting with SAM. We do make quite a bit of use of the generic system in this way. Some of our users do as well. You would, if you're importing profiles that you've generated from somewhere else, you would also probably want to make sure to pay attention to this plant loss input and make that 0 so that you're not adding additional losses that you have likely already calculated on top of your generation profile.
Thank you. We have a couple of questions about modeling hybrids with diesels or natural gas generators. One is a question that comes with a suggested solution, which is we know SAM hybrid system is not able to simulate system with diesel generator, but may one use fuel cell or other mechanics to simulate such a system?
Yes, so that is a great question. I think that, again, there's probably two ways you could do it depending on how you're looking to model your diesel system. One would be to use the fuel cell option. If you can go ahead and actually click into it so you can see some of the input pages. If you can simplify some of these types of inputs to get this to behave enough like the diesel generator or other type of generation technology that you're trying to model, then that is definitely an option. I will say that that's also probably a great application for the generic system combination here. So if I open up the generic system one, you'll see at the top here that same power plant input page that I was showing before, where you can add a generation profile if you have one you're calculating in an external tool. Or you can have just sort of constant generation. And then you can also account for fuel costs that would go into the financial model in that way. And in this one, you would then have to basically zero out the fuel cell to get it to not look at a fuel cell. So I think depends a little bit on how much detail you're trying to model the diesel generator. SAM isn't explicitly meant to do that. You could hack it a little bit in one of these two ways, or there are other tools that do specifically represent diesel generators and hybrid systems that may be worth looking into also. And I don't know if anyone else on the team wants to add anything about how they have hacked modeling diesel or other generators in the past.
Yeah, I think we have some of our users have used the fuel cell to model a diesel generator. It's basically something that converts a fuel into electricity, so it's suitable for that even if the inputs aren't explicitly labeled as a generator. So if you are trying to do that, we can help you with that. And let's see, here's another one about wind. Just wanted, oh no, I think we answered this one. So if you want to model a wind system, a wind hybrid system, then you can run the wind model, get your hourly results out of the wind model, and use them as input to the generic system model. And that would work for a hybrid system or for a wind storage system. I guess and then so you've got a few more questions here. So can we load wind and solar energy yield assessment done separately? No, I think we answered this one. Sorry, I'm.
No worries.
It's a bunch of questions here, and I want to make sure we're getting them all. Oh yeah, there's two here about grid connected hybrid systems. So can we model grid supply and PV as a hybrid model? And can we include the grid load in a hybrid system?
Okay, I'm going to take a stab at what I think those questions are asking, but please feel free to type in clarification if I miss what you're talking about. So for I'm imagining this is talking about a behind the meter system where the grid load would be the electricity that you're purchasing from the grid. So yes, with our behind the meter systems, which are housed under distributed here, you can account for the electric load. So this is basically your electricity consumption data on a time series basis for the building or set of buildings that you're trying to model. You can input them on a time series basis and scale those to some kind of monthly energy. We do have other videos, I think, that go into more detail on this, but we have macros available to help you download typical load profiles and scale those to a monthly bill. or we do have a sort of simplistic, sorry, nope, that's in a different model, sorry. So yes, you can input your electric consumption data, and then this model does look at how the generation from your system offsets your electricity usage, and that is how it is calculating the value of the system to the host, as we're calling it, which is the person owning the building. So if I go ahead and simulate it, I can show a little bit of those outputs dealing with the grid side of things. So it shows, you know, the net present value for that host, which is the person that has the electricity load. And we have a whole variety of output variables dealing with the electric load as well that I can search for just by typing load up top. And again, we have webinars that go into a little bit more detail on that. The other thing that is relevant about the grid for both behind the meter and front of the meter models is this grid limits page. So this is where you could represent if you have an interconnection limit, which will basically not allow the hybrid system to export more power than that to the grid. So if I were to enable it, I can set what that interconnection limit is. I can also set curtailment separately, which allows me to specify a maximum AC power at a given time step that is allowed to be exported. So this would usually apply to larger front of the meter utility scale systems that are potentially being curtailed by the grid operator. So you can represent that in there as well. And for behind the meter models, we do have this grid outage capability that again is covered in other webinars in more detail, but that would be another way that we're representing sort of how the grid interacts with the system. SAM does assume that the hybrid systems are grid connected. SAM assumes all of the systems that we model are grid connected, other than any outages that you might model. And we do have some checkboxes on the battery page, specifically the battery dispatch page, that deals specifically with how the battery can interact with the grid. So whether or not the battery can charge from the grid, and depending on which dispatch method you use, you can select things like whether or not the battery can discharge to the grid, etc. So a series of checkboxes that control specifically for things with batteries, how that battery is allowed to interact with the grid. Hopefully that answers your question, but feel free to read out any follow-ups if I misinterpreted what you were asking.
Thank you. And we have a follow-up comment on the questions about diesel generators, which is that it says you can leverage NREL REOPT for some diesel hybrid system analysis. So that's a good point, that REOPT is a separate tool from SAM that's available from NREL. And NREL does, SAM does interact with the REOPT API for battery sizing if you're modeling a PV battery system. But that's a great point, that if you're modeling hybrid systems with diesel generators, you can check out the REOPT website.
Yes, absolutely. REOPT typically does more of the system sizing optimization. So they do run an actual linear optimization for sizing, and then also for battery dispatch. And as Paul mentioned, we can import some of those results into SAM, where you might then want to sort of tweak the optimal system size or dispatch, or take a look at some of the more detailed voltage and current characteristics of your battery. But REOPT is a great tool for a lot of behind the meter hybrid systems, and does, as Paul mentioned, have a lot more information on, and the user mentioned, I guess, a lot more information on modeling diesels and a couple of other technologies that aren't available in SAM, such as combined heat and power.
And then there's a question, a couple questions about modeling CSP wind or CSP PV hybrids.
These are great questions. That's a technology combination that we're definitely interested in. I believe over the next couple of years, we are hoping to be able to take a look at CSP plus PV with an electric battery and possibly thermal storage as well. We don't have CSP wind on our current roadmap, so would love to hear more about some of the different combinations that you guys are interested in. As I said, the availability of some of these configurations is funding dependent, so we like to collect user requests to understand, priorities of folks in the industry and what kinds of ways you're using SAM, what kinds of ways you want to use SAM but can't, and that helps us know what types of resources to ask for or to propose into different proposal opportunities to see if we can get some funding to add some of those features. So the more we hear from you, the better case we can make, and the better we can direct what we think will be useful to people trying to model things with SAM.
All right, I think that's all. I think Brian may be clarifying the question of whether REOPT is applicable outside of the US.
Should I just answer that live?
Sure.
Yeah, so REOPT pulls PV watts for weather data, and we are working on getting weather data into PV watts for most of the world between 60 north and 60 south. So once we update PV watts, REOPT will update in that way as well. You do have to provide custom utility rates to REOPT. It only pulls utility rates automatically from the US utility rate database for those, or for locations in the utility rate database, which is focused on the US. And then you do have the ability to upload custom generation profiles for resource data outside of the US.
Thanks, Brian. It looks like all the questions we have either answered by typing or answered live here. We have a couple minutes, so we can wait to see if any other questions come through.
Fantastic. And while we're waiting for that, I'll thank everyone for coming to the webinar today, for participating, for listening, for sticking around, and for asking really great questions. And as always, feel free to reach out to us. We have a pretty active user support forum that Paul monitors, so we do participate and provide answers that way. And we also have our SAM support email that I'm showing here for if you're interested in working with us, or questions that may be a little bit more involved or involve proprietary files, things like that. And we're looking forward to interacting with you through any of the various ways that we have.
And it looks like one question did come in here. Does the hybrid system model equivalent CO2 emission curtailment?
No, the models in SAM do not currently calculate equivalent CO2 emissions or deal with any type of curtailment due to emissions currently. That's another thing that the REOPT tool can be useful for, is taking a look at some of those emissions calculations, if I'm not mistaken.
And then this is a question that's not particularly specific to hybrids, but it's about PV string size.
Sure.
And it's, where in SAM can a PV string size be determined?
Well, depending on what you mean by that, let me go ahead and go into the bonus round here. I'll take a look at the detailed PV model. So PV watts makes a lot of assumptions about the actual PV panel, the inverter, and the electrical sizing of the system so that users don't have to do that kind of sizing. So if you're using PV watts, there isn't an option to size the strings. We're doing it automatically behind the scenes. In the detailed PV model, you can specify the electrical layout of the system on the system design page. So you can specify the number of modules per string and strings in parallel. There is a little bit of feedback on the bottom based on the voltages, relative voltages between the panels and the inverters that you've specified. And we do have a macro that we are hoping to update soon to take a look at this one, Paul? I'm not remembering.
Yep, that's right. System sizing.
Thank you.
Yep. So this uses an older method for figuring out the string size. You know, if you're trying to figure out what the maximum open circuit voltage is under worst case conditions, this macro does it using an older method. We're planning to update this for the fall 2024 release to use more current approach to this.
And I would encourage you, if you're interested in more details on the PV model specifically, to check out the SAM website, which I'll go ahead and just quickly bring up here. Along the left-hand side, there's categorization by technology. So we have for PV a bunch of videos, publications, information on where we get cost and component data, validation, etc. Similar types of things for videos that are applicable to batteries, wind, marine, etc. Some of the simulation options that I had mentioned, so things like uncertainty, parametric and statistical simulations, input browsers, so some of the things that are applicable to all technologies, more information on financial models, weather data, etc. So definitely a lot of information available on the website to get more detail about things that I may not have covered in the hybrid webinar today.
All right, I think we're about a time. We have a couple of questions here that are coming in that are a little off topic. There is a recommendation that we add like a single line diagram representing all these configurations, which we appreciate that input. And then another question about the system sizing macro. Doesn't take into account current limits, which is correct. But I would encourage both of those folks to follow up on the SAM forum that's NREL, https://sam.nrel.gov. And so we can follow up on those suggestions and comments.
Wonderful. Then thank you everyone for joining the webinar today, for your participation and questions, and we look forward to hearing from you more in one of our various ways to interact with users. Thank you.